Hi, welcome to the pre-calculus lecture series. And in this video, we're going to talk about, is for the section 2.8. We're going to talk about is one-to-one functions and how to find their inverse here. So first we're going to define what is a one-to-one function and then how we find the inverse of the one-to-ones here. Okay, so now let's go to our worksheets here. So let's start. Okay, so let's take a look. The first definition is one-to-one functions. Okay, so what is a function? What is a one-to-one functions? Okay, so we said here, we said a function with domain A is called one-to-one if no elements of A have the same image. Okay, so have the same image. That means if f of x1 is not equal to f of x2, then whenever x1 is not equal to x2, see here. Okay, what's that mean? Okay, so like when first we start this chapter when we define the functions, right? So we say the functions here is kind of like, you have the, you define the relations here. So this is set A and this is set B here, right? So we say the functions here, you have some values here, right? And then for the here, you have some values here, right? And then the function we defined is as a relation from here to here. So this is a function. So we say the function, as long as one value in the domain, you can find one value on the range. So like in here, you say, okay, this one's here, and this one's here, right? And so let me get rid of this one's here, right? Okay, or like let me put one more here. So here, so we have another ones here. So like in the function we talked before, we said this relations here, right? So if you go here, and then for these numbers here, right? So if I have two values in the A domain, they both go into the same values here, right? We say this is okay, this is still, it's a functions, right? So the only one they violate the function, that means if the one value in the A, you go to the two values of the B's here. So this is still a function, okay? But then you take a look here, because both of these values go to the same value. So this is a function, but it's not what? But it's not a one-to-one. Okay, so we talk about the one-to-ones. That means if this one's here, this is my A, this is my B here. So if I have four values here, if I have four values here, then if I have a relation I defined like this way, this way, this way, and this way, right? So if every value in the A, you can only find one value in the B here. So we say this is what? This function is a what? Is a one-to-one, right? Okay, so this function is a one-to-one function. So the one-to-one functions, okay? So how do I check a one-to-one function? You can do, you can use the graph to check it, or you can use the algebra relation to check it. Okay, so the graph to check it, we call this a horizontal line test, right? So what is a horizontal line test? We say if a function is a one-to-one, if and only if no horizontal line intersect its graph more than once. Okay, so like for examples here, right? So if I have a function like this, okay, so like this is my functions here. So if I have a function something like this, and then we say, hey, this is the, so if this is f of x here, so we say, hey, this is the, this is the one-to-one function. So what is horizontal line say? Horizontal line say, hey, if you put a horizontal lines here, then this horizontal line touch this function at this point and then this point. So, this one's maybe is x1, this one is x2 here, right? So the both of the fx1 give you the same values here. So let's say it's kind of like this situation. Both of x, x1 and the x2s here, right, give you the same value. So that's why this is not one-to-ones, right? So that's why we say this is not one-to-one. This is how do you use the graph to check it. Also, you said, hey, sometimes the graph is probably is difficult, right? So the graph is difficult. Then how do I use the algebra to check it, right? So, using the algebra to check. So the way we check here is, you will set, you set f of x1 equal to f of x2. That means if they have the same values here, then you have to solve, then the x1 has to equal to x2. That means you cannot find more than one value to satisfy. That's what we talk about the horizontal line test. Also, like if the horizontal line, you cannot draw the picture, and then this is how to use the algebra way to find it, right? Okay, so now let's take a look. See here. So what is the, if this is one-to-ones here, right? Okay, so like in here first, if you want to use the graph to check it, right? So this function is what type of function? Cube functions, right? So this function is go like this. And then if you do a horizontal line, so if you take a horizontal line here, horizontal line here, horizontal line here, right? So every horizontal line, you can only find what? You can only find one value. So that's why from the picture, we say, yes, this is one-to-one, right? From the picture, okay? So now if you want to see how do I, do the algebraically, so you say f of x1 equal to f of x2. That means x1 the cube equal to x2 the cube. So when you take a cube root, so it's x1 equal to x2. So you only have one value, right? So that's why we said this is the, one-to-one. Okay, so let's take a look at this one here. The second one's here, right? So let's do here. So for these functions, right? This is quadratic. So this is my functions here, right? Okay, so now let's take a look at the horizontal line test. That means you put the horizontal lines here. How many points you have? 2. So we say, hey, if it's 2, then what is here? So this is not what? One-to-ones, right? Okay, so let's try to use the algebra, try to save it, so solve it. So we say fx1 equal to f of x2. That means x1 square equal to x2 square. So when you try to solve it, you will find x1 equal to x2 or x1 equal to what? A negative x2s, right? Or the x1 equal to the negative x2s here. So that means in here, you have, for one x here. Okay, so this is, This is the negatives, right? So that means you will get two values, right? So you get x1 equal to x2 or x1 equal to x2. So you got a 2. So we say you only can have 1. So this is not, right? So this is not the 1-to-1. Okay, so let's do the last ones here. Let's try to use the algebra to solve it here. So this is x1 equal to the x2, right? And let's see, does x1 equal to x2 is the only solution. So this is a 3x1 plus 4 is equal to the 3x2 plus 4. Okay, so I minus 4 both sides. So I got a 3x1 equal to the 3x2. Now I divided by 3 both sides. What I have x1 equal to x2, right? So for if the function value equal, then these two has to be the same value. You cannot have a true value. So we say yes. This is 1-to-1. Okay? All right, so let's take a look. Okay, so if a function, the inverse functions, right? So if for the inverse functions, one of the reasons why we want to say this is 1-to-1 function, because in order for inverse function to exist, it has to be 1-to-1. You will see why. Okay, so let's first take a look at what is the definition of the inverse function. So we'll say let f, right? Let f be a 1-to-1. Okay, function with domain A and range B. Okay, then its inverse function, we use this notation f inverse, right? F -1 inverse has domain B and range A. Okay, so we use this, we say f of the inverse y equal to x, or the function is f of x equal to y here for any y in B. Okay, so let's take a look at what that means here, right? So we say the functions, right? So so this is the function, right? So this is A, this is my domain. If I from the A to B here, right? So the functions, okay, so function is a relation you go this way. So if this is the function f, then when you go backward here, so when you go backward here, so this is, we call this f inverse, right? So that means the f inverse functions here. Okay, let's take a look at why it has to be, the 1-to-1 is why it's important here, right? So if you take a look here, let's say here, I have, this is 1, 2, 3, 4, and then I would say here, I have 1, 2, 3, right? Okay, so now for the f functions, right? So we said the f we can define like this. Okay, so the f here, you say this one go here, these two go to the same one, and this one go here, this one go here. All right, so f is a function, but if you take a look at the f inverse, that means I go backward, right? So this function, this values here go backward here, that's okay. This one go backward here, that's okay. But for this ones here, when I go backward, is what I have two values, right? So I know, the one value cannot have a two if you define the function, then the f inverse in this situation is not defined, correct? It's not defined, so that's why, because this is not 1-to-1, so it's not defined. So if you have the functions here, right? So let's take a look. This is domain A and this is B. So this is the functions, right? So this is the function. And then if you go backward, here, this is, we call this inverse. Okay, so now let's take a look at this relation. If I have 1, 2, 3, 4, and I have a 1, 2, 3, 4 here. Okay, so it see here, right? So if you have f, so these ones go here, these ones go here, this one goes here, this one goes here. So the green function is a function. Now I take a look at inverse to see the inverse exists or not. So inverse said, hey, this one go back here, this one go back here, this one go back here, this one go back to here, right? So the inverse is also a function. So that is because we said this is the, one-to-one, make it. Okay, so here, right? So the f functions, right? So this is what we call this f function. F is from the A to B. So the A here is the domain of the f function, and the B is the range, right? And then you see the inverse is f inverse is from B to A. So what happened here? This will be the domain of f inverse, and this is what we call this ranges here. All right, that is what we call this the inverse. Okay, so the domain, the range will switch also. Okay, so let's try to practice some easy problem to see we'll be able to understand that. Okay, so let's say find the f inverse for the specific functions here. Okay, so now this is f of 1, f of the 3, f of the 8, right? Okay, so let's try to see here. So let's means here. This is A, that's domain. This is B, right? Okay, so the one I have 1, 3, 8, right? So that is the 1, 3, 8, right? So that's what this one is 1, 3, 8, right? So that's why this one goes to the domains here. And now I have here 5, 7, negative 10. So this is 5, 7, negative 10, right? So this is what will be my ranges here, right? So here. And then the function I defined is f1 to 5, right? f3 to 7, and fa to negative 10, right? Okay, now in here, okay, so now the f inverse is here, right? So the f inverse is what? You go backward, right? So now the f inverse, so what is the 5 go backward here? Backward to what? To 1. So this one is equal to 1. What is the f inverse 7? So 7 is this one go backward. What is here? So this is 3. So f of inverse negative 10 is this one go backward. So what is this one here? This one is 8. Right? Okay. So that's how do we find the f inverse. So the next thing here, we will say, how do I check? Are they, what is the property of the inverse properties here? All right. So I will say here, I said let f, right, be a one-to-one function. Right, with the domain A and the range B. Okay, so the inverse function so the inverse function, we use the f inverse satisfy the following cancellation property. So what is the cancellation properties here? That means if the f inverse and the f, then the x here, I typically say the inverse and the f is kind of like the enemy when they bump into each other. So like in here, the f inverse and the f, they see each other. So since they just kill each other, so it will be the x here. All right. So that means the x is what? So for all the x, in the domain A's, right? So, or if you go backward, you say F inverse X here. So the same way, the F and F inverse, they see each other, seems like the enemy, they kill each other. So this one is X here, right? So we say, but this is for the F inverse. So this is all the X in B's here, all right? So that's how do we say this is the inverse. Okay, so now the problem number 3, example like number 3 is here, say, hey, check to see they are the inverse function or not. So that means I'm doing a composition of the function. So first one's here, I will say f of gx, right? This is a composition function, f composite g. So that means every number, every value in the x, you replace with gx. So it's x 1/3 to the 3 half. What you have here is x. Then we do the other way, the g composed of x. That means everything in the g I replace with x. So this is x to the cube. Then this is 1/3. So 1/3 times 3 is 1, right? So this is x first. So it's x. This one, right? Don't skip the steps here. Okay. So now, so how to find the inverse after one-to-one functions here? Okay. So the one we say, okay, how do I find it? Okay. So here we have a few steps here. You can switch the step. It doesn't matter. So first, let's write as y equal to f of x. So I have y and x. And the number 2 is here. I will be solve the equation for x in terms of y. And then number 3 is here. We say interchange x and y. Okay. So the resulting equations is y equal to f inverse x. Okay, so this is the one. So some teacher, they switched, they can switch like the step number 2 and step number 3 is here. Some teacher, they will say that before you even solve the equation, the steps, they say, okay, they said interchange the, so they interchange the x and the y first in the step number 2. Then the step number 3, then they solve the equation because they interchange, so they solve the equation y in terms of x. So some, in terms of x. So some teacher use the first part, or some teacher they switch the step number 2 and 3. Okay, so let's take a look at number. Number 4 is here. I said find the inverse of the functions, right? So we can use either way. We use the method the book talk about. So it's the one I highlighted in green. So we'll say y equal to the 3x minus 2, right? So I solving for x, all right? So solving for x, so it's plus 2, plus 2. So it's y plus 2 equal to 3x divided by 3, divided by 3. So I will get x equal to y plus 2 over 3. Then the last step, switch in the y and x. So y is equal to 3x plus 2. So this is my f inverse x here. Okay? All right, now let's take a look at the next ones here. So the next one is the same thing. I say it's y equal to 2 x fifths minus 3. Solving for x, okay, times 2 both sides, right? So this is 2y equal to the x fifths minus 3, plus 3 both sides. So this is a 2y plus 3 equal to the x fifths. Then take the fifth roots, right? Okay, so that's why you will have here 2y plus 3, the fifth root is equal to x. Then last step, switch the x and y. So y is equal to, here, this is 2x plus 3 to the fifth root. So this is, we said this is f inverse x. Good? Okay, let's try to do one more. Okay, so the one more is here. So, you know, we say y is equal to 2x plus 3, x minus 1. I want to solve for x. Okay, so times x minus 1 both sides. So this is x minus 1 to y. So this is x minus 1, 2x plus 3 times x minus 1. Okay, so these two cancel. So you get xy minus y is equal to 2x plus 3, right? Okay, so now what I can do is I can plus y. All right, so I have xy equal to the 2x plus what? I have 2x plus 3 plus y, right? So minus 2x minus 2x. Okay, so if minus 2x, I can have the x out, right? So I have y minus 2 is equal to the 3 plus y, correct? Okay, so now I divided by y minus 2 divided by y minus 2. Okay, so that's why I get an x here is equal to 3 plus y minus 2. So now I switch the x and the y, so I switch to, so this is y equal to the 3 plus x minus 2. So this is my f inverse x. Okay, so it's always the same procedures, right? Okay, so now the graphing of the inverse function, this is quite interesting here. So the graph of the f inverse functions here is obtained by reflecting the graph of y of f in the line y equal to x, right? Because we know from the properties, the inverse function, right? So f inverse, the reason why this is y equal to x, because we know from the properties here, we said the f of the f inverse is equal to x, and f of inverse f of x equal to x, right? So that's why it's, it's reflecting, all right? So let's take a look at it. Say sketch the graph of y equal to the x minus 2. And then use this graph to sketch the graph of the f inverse. Okay, so the f of x equal to the x minus 2. And the parent function is what? Parent function is equal to square root of the x, right? So this is minus 2. That means I am what? I am shifting to the right 2 units, right? So it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 1, 2, 3, 4. Okay, so here 5, 6, 7, 8, 9. Okay, so we know this one's here is a shift parent function, right? So we said the parent functions. Let's try again. We have a few keyword, key point 0, 0, 1, and 1. And what is here? It's 4. This is what? It's 2, right? So the parent function is go like here, 0, 0 here, 1, 1 here, 4, 2, 1, 2, 3, 4, 1, 2, 3, 4 is here, right? So parent function, I go kind of dot lines, right? Okay, now I'm shifting to the truth here. So for this function, shift to the right to the truth. So this first point is shifting to here. The second point go to here. The third point is 4, right? 1, 2, 3, 4, shipping 2, 1, 2. So here, go here. Right? Okay, so now this is my functions, right? So this is my functions here. Now I can erase my parent, so I won't cause any confusions here. Okay, so this is my functions here. So this is the function. We said this is the y equal to the square root of the x minus 2. Okay, so now we said, hey, let's try to find the inverse. So the inverse, remember, is reflecting over to what? X equal to, so it's reflecting over to this axis, right? So this is a diagonal, just divided to 45. So this axis. So my F inverse will be this. Take a look here. So this 2 going to reflect into where? To this 2. So going to go here, right? And then this 1, 1, so go to here, right? So then this 1, 1, this 1, right? So it's a 3, 1 going to go here, right? So this will be my F inverse, right? So that's what is we call this reflecting to the y equal to the x here. Okay, so now they want to try to solve it, all right? So let's try to solve it. Okay, so we say y equal to the square root of x minus 2. Now solve for x, square both sides. So it's y squared equal to x minus 2, then plus 2 plus 2. So I have y squared plus 2 equal to x. Then what is the last step? I switch the x and y, right? So I have y equal to the x squared plus 2. So what is this? This is F inverse x. All right, that's it. Okay, so this is the section. It's a very important section to show us how to find the inverse functions here, right? So some key point you need to remember. The first, the function has to be a one-to-one function before you can find the inverse, okay? Then the inverse function, also the other good property is inverse functions, to each other, they are reflecting over y equal to the x, these lines here, right? So that means the inverse and the function itself. So this is f of x, right? So f and f inverse, they are reflecting over these axes here. And then the third thing here, we need to know how to find the inverse function. So the first thing here, you solve for x, right? So you have y equal to your function, and you solve for x. After you solve that, then what you do, you switch the variable of y and x, and that will be your what? That will be your f inverse functions here. Okay, that's it. And it's nice to talk to you, and hope that you get a good understanding about what is the inverse functions. All right, and that's it. Have a good day. I'm looking forward to talk to you in our next video. Okay, bye.